Hello, coach. Before we start the practical experiment, we need to take a look at this and to see the theoretical calculation. The only reason for this, the most important reason for this, is to find where to put the hinge. First of all, we need to find the area of the gate, and the very main point, which is the centroid of the gate, is very easy to find, which is 7.5 centimeters, as to the height is 15. This is all about the area and the height of the gate, and the centroid of the gate, sorry. And what you see in here is the second moment of area. We would use that to find y of r. This very detailed will show you I will describe it very simply, which is the pressure distribution on the gate, and the height is all written in details. The main thing you need to know, this is the force. The force acting on the gate will depend on the density, the gamma, which is density times gravity, height, and the area of the gate. We know that the density would not change, so it is fixed, and we know that the area of the gate would not change. So the only thing that causes the door to open would be the change in the height. So we'll try to see at we predict that the height of the water would be 25 centimeters, and we use that in the equation to find y of r. This is the location of the force acting on the gate, which would be at 8.6 from the bottom of the wall. As you know that the force would be at 8.6, the proper thing to do is to put the hinge lower than that point. So when the force is acting on it at 25 centimeters, the height of the water is at 25, the door will be able to open. So that's why we decided that we put the hinge at 7.5. Now let's watch the experiment we did in the field.
Hello folks, my colleagues Dilman Yassin, Rolan. We will try to represent this experiment, which is about the force caused by a static fluid. In our case, it's water. We will try to see if the gate of our boxes would open with the change of height of water. Now let's see what's the inside the box.
Now we can see what we have inside of the box. Roland, can you come close, please? As you can see, this is our box, and this is the gate of the box, and that is the hinge of our gate, and we use this ruler to the height of the fluid.
Can you tell us what's the fluid that you're using?
Yeah, of course. In this experiment, we use water as a fluid.
Okay, and can you tell us what the magnetic force on the gate depends on?
Yeah, it's directly proportional to the area of the gate and the height of the water,
Okay.
and the density of the water.
Okay. Hello. Since Dilman said the resultant force on the gate depends on the height of the water, the density of the water, and the area of the gate. And in our case, the density is not going to change, and the area of the gate is also fixed. So the only thing that will change the force is the height of the water. So now we will take we will repeat the experiment 3 times. Once in the height of 10, and then in the height of 20, and after that we will fill the box till 25 centimeters, and we'll see if the gate which of them will open. And now we will fill the box with water.
As you know that we're going through 3 experiments, we'll take 3 measurements at the height, but I just want to make something clear, so could you come close? The reason that the hinge is not on the centroid, if it was, we would need a very big box, which we need to be very high. So it will act, we would need a very large amount of force to act on the gate so that the resultant force would go above the hinge. But since due to that we put the hinge below the centroid at a point that we don't need that much height to affect the door and make it open. So now we will fill the box to see at the 3 levels that aforementioned, at those 3 levels, if the gate would be able to open or not. So Dilman will fill it up. Now we'll wait and see to take the first experiment, to take the first measurement, which would be at 10 centimeters. Now the water is very close to 10, so let's take a look at in front of the gate and see if this will be open. As you see, there is water drilling out, but that doesn't cost that much. But as you may see, the door is not opening yet. So let's take a look at 20 centimeters. As the height increases, the force acting on the gate would increase.
And it will come much higher till it comes above the hinge.
As Dilman explained, which is proportional.
Yeah, directly proportional.
Kamal, can you take a look at?
Okay.
Now,
As the water height increased, then the pressure increased on the gate, and we can see there's a force on the gate, but it's not enough for opening it completely. Take a look at the height of it.
Now the height is at 15 centimeters.
So you need 20.
So we'll wait for the third measurement, which we'll take at 20.
You need extra water to open the gate completely.
Saman, can you take a look at the gate?
This is the maximum point that the door will open.
And as we can see,
The measurement is at... What is the measurement?
At
It dropped down. So
It dropped down.
At 20, the door will open, and the flow in would be equal to flow out. With the amount of the flow that we put in, now is equal to the amount of flow coming out. So the height will not increase, and the door will not open more than that. So the experiment has worked. So as a conclusion, Saman will try to tell the conclusion.
In conclusion, we found that the height of the water affects on the box's gate to open.
We took 3 measurements. At 10 and 15, the door didn't open because there is no much force acting on the gate.
But we found that at 20, the door of the box opened. And in that point, the height of the water did not increase anymore because the flow in equals to the flow out.
as a notion, as we saw at the first 2 measurements, the water was leaking out from the bottom side of the door, but it wasn't affecting on the height of the water, so we're gonna neglect that.
And as you may notice, we put this stop over here, and you may ask why. It is because the water was pushing the door, and this door was opening a bit in this side, which did affect the water to come out in a large amount. So the only thing that this is doing is stopping the gate to open in the beneath part. So this would help us only to make the door to open at the above part. That's it.